Hello, welcome to your video on solving radical equations. You will be able to solve equations that are involving radicals. First question is, how do I solve by isolating the radicals? So just like you would isolate for x or y, whatever your variable is, you would also isolate for when the radicals involved. So here's an example problem. And here you're going to subtract 7 to create a zero pair. Now you have the square root of x equals 9. In order to undo the square root, you're actually going to square it, which will leave you with x, and then 9 squared is 81, so x is in fact 81. Another type of problem you might see will look like this. So same type of format, you're going to try to isolate the variable. So what you're going to do is subtract 8 on each side, and then you're left with the square root of 3y equals -6. Then you're going to square each side to get the variable by itself, or sorry, to get rid of the radical. So I'm left now with 3y equals 36. Then you're going to divide by 3 on both, and you get y equals 12. Now, at first glance, that looks like it's going to be an answer, but you always need to check your answer, and that's something I didn't do in that first example that you should do all of the time. It's a great habit because something might appear to be the answer. In this case, y equals 12. But when I plug it in to the original, so square root of 3 times 12, and then plus 8, equals 2. Square root of 3 times 12, square root of 36 is 6. 6 plus 8 is 14. 14 does not equal 2. So in this case, there would be no solution. So you really want to go back and check. So this one, I'll check it. So square root of 81 is 9 plus 7. And that in fact does equal 16. So I know that my answer is correct. How do I solve a radical equation? So here's a word problem for you. This one, you're still going to isolate the variable. Just going to go about it in just a little bit different of a method. The time t in seconds takes for a pendulum is using the equation t equals 2 square root of L over 3.3. And then if it swings for a full 3 seconds, what's the length of the pendulum? So here you're kind of solving a word problem. But what I want you to do is use this equation here. And so that we're going to take that, and then it says 3 is your time. So 3 equals 2 square root of L over 3.3. And you're going to divide each side by 2 because we want to isolate that radical still. So now I have 1.5 equals square root of L divided by 3.3. And then to get rid of the square root sign, we have to square. And that's going to give me 2.25 to equal L over 3.3. Then to get L by itself, I have to multiply by 3.3 on each side. And that's going to give me 7.425 for equaling L. And because this is a word problem, we're talking about 7.4 feet long for the length. And then, of course, you want to check your answer to make sure that it does work. And in this case, when you plug it in, so 7.425 over 3.3. When you solve that, you do get an answer of 3, which is what you need. So that one's correct. Here's another type of radical equation that you might encounter. This one's just a little bit different, so I'm going to speed through this here. To get rid of the square root, you need to square everything. So n squared equals n plus 12. And then we are going to move everything to the same side. So n squared minus n minus 12 equals 0. And that should look very familiar to you. Since it's a quadratic, we need to factor. And what will give me a product of 12 and a sum of -1? Well, that would be -4 and +3. So n would be +4, or n would be -3. Now you need to check both of these as a possible solution. And what's going to happen is that one of them doesn't work. So when I substitute in 4, so 4 equals square root of 4 plus 12, that's going to end up giving me 4 equals 4, which is true. And then if I put in -3, so -3 equals the square root of -3 plus 12, I'm going to get -3 equals 3. And that's not true. So this answer is what we call an extraneous solution. It means that solution doesn't check out with the original equation, but there is one that does, in this case n equals 4. So it's not no solution because there is just one of the two that works. How do I solve with radicals on both sides? You kind of see it a little bit, but really quick, this is how it's going to work. You're going to square both sides to get rid of the square root symbol. So 5t minus 11 equals t plus 5. And then from there, it just becomes normal. 4t minus 11 equals 5. And then 4t equals 16. So t equals 4. And then check your answer, plug it in on both sides, and you will get it that it does in fact work. So it is a solution. Your turn. Here's your 2 problems to solve. Show all of your work and then check in with me for the answers. All right, here are your solutions.